Good morning, everyone. Before I get started, I just want to thank the organizers for putting together this workshop. For those of you that don't know me, my name is Lisa Bettis, and I'm the Associate Director for Advanced Computing Enablement at High Performance Research Computing. This morning, I'm going to be going over the scientific machine learning resources currently available at HPRC, and more importantly, some very interesting and transformative resources that will be available soon. So High Performance Research Computing, if you're not familiar with our facility, we're an interdisciplinary research environment, and our overarching mission is to enable research and discoveries that advance science and technology. Okay, so our goal is to enable computational and data-enabled research for researchers at Texas A&M University, and we do that through a variety of resources that we provide, which includes consulting, documentation, and training resources. So our overall profile, we operate 3 HPC clusters that have over 900 teraflops of total computing capacity and a large amount of disk, over 14.5 petabytes of storage. The names of these clusters, Vital, Terra, and Ada, might be familiar to some of you. What's really important about these clusters is their access is open and free of charge to all faculty and research staff at Texas A&M University. Okay. You do get access through a proposal allocation process, but we have excellent support to get you going. Our staff consists of 14 professionals, and we have 9 student workers to support researchers. The funding for our facility does come from the Division of Research. Here's a list of key resources or key services that we have available. First and foremost, we have compute cycles, okay, storage and networking for researchers at A&M. We have the allocation and new user startup assistance, individual consulting and help desk services. I'll talk a little bit more about all of these key points, including the advanced support services. We have a liaison program, which is part of the enablement component that I oversee, which includes researchers from the College of Science, Engineering, Geosciences, and we are actively looking for a researcher, assistant research scientist, or some level of research scientist in AgriLife to include in our enablement group. We have expertise in many of the different science and engineering research domains, and we provide a lot of training resources. So a little introduction to the hardware that we have available for our compute cycles. We have Terra and Ada. This slide gives an overview of the compute power that these 2 HPC systems have. I just want to point out a couple of key points for this hardware that will be important in the scientific machine learning domain, the GPUs that we have available on these systems. Okay, so Terra is one of our newest systems. I'll be talking more about the really exciting ones that we have coming up in the next couple of slides. But we have 48 GPU nodes, the NVIDIA K80s, okay? And on Ada, which is our bigger system currently, we have 30 GPUs with the NVIDIA K20s, okay? Ada also has 4 GPU compute nodes that have the NVIDIA V100s, which will be transitioning to Terra very soon. If you are familiar with Ada and you are interested in some of the resources, you might want to visit our page. There's an RFP. We will be decommissioning Ada soon in preparation for the new system that we'll be having online shortly. So if you are interested in that, you might want to visit our webpage and look at that RFP about getting some of the compute nodes for Ada. So I would like to point out one of our newer systems named Vital. This is a very interesting system. If you have a need for doing research, large-scale research with data sets that need to have a higher level of security. So maybe you have a data set that is within HIPAA, it has, need HIPAA compliance, or some other high-level security for that data set. VITAL may be a system of interest to you. Okay, so it's a very secure and highly compliant computing environment. It does have NVIDIA V100 GPU nodes available on it, and it is our only system that also offers Windows as one of the operating systems, and it also offers Linux. You can use either the Windows or the Linux environment, depending on your research needs. It does have a substantial amount of disk available to it, 2 petabytes. Like I said, more importantly, the VITAL system is a highly secure and compliant system that will fulfill your needs if you have regulated data that you need to perform research on. This is also housed in the very secure West Campus data center. Okay, so here's an image that we have here, which has security guards and a lot of security protocols to get access, physical access, and security network-wise. So here's our main focus on some of the new and upcoming hardware that we will have available. This is currently in deployment. As we speak, it's being deployed in the West Campus Data Center. I've spent the last couple of weeks over the West Campus Data Center with the deployment team, along with a couple of other HPRC staff. So what I would like to point out for this wonderful new resource that we'll have that will be very important for enabling the scientific machine learning projects is the number of GPU nodes that we'll have that will include the NVIDIA A100 GPU nodes or GPUs. The NVIDIA A100 GPUs are very exciting, and I can't wait to get my hands on them. One of the unique things that the NVIDIA A100 has is that it's a multi-instance GPU. So if your project can't utilize the entire NVIDIA A100 GPU, it can be sliced up into 7 unique and distinct instances, which means that you can have up to 14 instances of GPUs on a node where we have just the 2 NVIDIA A100s. So it's a very unique characteristic of the A100. This is a very powerful GPU. So when you run out of resources on your local computer, you can come to Grace, and when we have it fully deployed and available for researchers to use, and run some very large-scale machine learning applications using these NVIDIA A100s, and we will have 100 of these compute nodes. We will also have a number of compute nodes with single precision T4 GPUs and RTX 6000 GPUs. In addition, we'll also have large memory compute nodes if you have some CPU intensive. These GPU nodes will also have very powerful CPUs on those nodes. So if your scientific application that you're coupling with machine learning requires both CPU intensive and the GPU, the scientific component and the machine learning component, these compute nodes will enable that research. The next system that we are going to have that should be deployed in the spring of 2021 is going to be called FASTER. FASTER was funded by an NSF MRI grant. Okay? And the unique characteristic of FASTER is that it uses this composable fabric. Okay, so in particular, we're going to be using the liquid composable fabric. The fabric allows for dynamically allocating the resources to the compute nodes. Okay, so this is very unique architecture. When you go to purchase maybe a machine learning box, if you spend a lot of money, you can get, 8, 10, 12, 16 GPUs in your box. But then that's it. You have that box and it's static. With the liquid composable architecture, we can have many different compute nodes with a pool of resources. We can have a pool of these GPUs, a pool of other resources available on the system, and you can dynamically allocate them. So if you need 16 plus GPUs on a compute node, you can dynamically assign them, okay? And we are going to have a large pool of the NVIDIA A100s on this system, and they will be dynamically allocated to the compute node based on your needs, okay? So on Grace, we will have 2 NVIDIA A100s per compute node, but on Faster, with the composable infrastructure, you can increase that to 16 or more GPU nodes. And the other really wonderful aspect of this composable architecture is that it's essentially hardware agnostic. If you need FPGAs, we can put in if you have the resources, we could potentially get FPGAs and put it into the system. If in the future, when there are software updates and you can go past the 16 or 20 GPUs, so it's only limited by the software on the system. So it's very flexible. And you're not locked into the hardware that you purchase at the time. So we're very excited about this resource that will be coming up, and it will be very unique and important in the realm of scientific machine learning. So we provide a lot of hardware, but that hardware requires that you understand how to use it. So we also provide a lot of training. So HPRC training short courses, this is a long list of training courses that we've provided in the past. I've highlighted some of the training courses that might be directly applicable to your research interests based on this workshop. The deep learning with PyTorch, TensorFlow, Python-based training courses, but we have a lot more. So I encourage you to visit our webpage that lists our training courses. I want to highlight an upcoming HPRC training course that we have this Friday, the Technology Lab using AI frameworks in Jupyter Notebook. This is being presented by Zhen Tao, one of the organizers of this workshop and part of the HPRC enablement group. He has many hats and does many things, and we're very lucky to have him. So it's this Friday. So if you're interested in that, please visit our webpage and register for it. It's free of charge, but you do have to register. And this is we'll be going over, it'll have 4 different hands-on sessions going over Jupyter Notebooks, data exploration, machine learning, and deep learning. So this should be a very interesting and informative training session. Okay. We have YouTube training videos that are available. So please visit our YouTube channel and peruse what we have. Previous training courses, not all of them, but a vast majority of them are listed on our YouTube channel, and we're adding more every day, almost every day. We have a lot of really good documentation. So when you first get started on the system, the YouTube training videos are very helpful. But when you need more detailed information after getting an introduction with the training videos, I encourage you to visit our wiki page. You can search for whatever is of interest and get more detailed information on how to use it on our systems. When you're first starting on a lot of these scientific and machine learning projects, getting the software installed and working efficiently can be somewhat difficult. We have a lot of software that's already pre-installed and optimized. If you visit our page on software, you can search for the software, find a listing of what's available, And then you can use the modules to load the software and set up your environment quickly and effectively. I want to highlight our advanced support program. Okay, this is where people become very important, right? So if you are starting a research project and you need some more advanced assistance, we have, as part of the enablement group, researchers with expertise in many different disciplines that can provide a higher level of support and provide time to really collaborate with you and or improve the workflow that you are utilizing on the system. So if you have an interest in the advanced support program, please email us at help@hprc.tamid.edu, and we can provide guidance and support in that area. So to access our systems, if you're a command line person, I'm command line away. That's where I like to live most of the time. But there are many applications that have more of a graphical focus, or if you're used to using more of the graphical interface to perform your research, we have the HPRC Portal, which is very helpful. We have a number of interactive apps that are already installed. MATLAB has some very nice machine learning plugins and subroutines. You can fire up a Jupyter Notebook or a Jupyter Lab through the portal. And we have training videos on how to use our portal. If you just have a graphical app that you want to deploy, and it's not listed as one of the interactive apps, you can use the VNC Portal. When you go into the VNC Portal, you'll get a basic desktop and a terminal, and you can fire up whatever graphical program you have that's available on our systems. Okay, and if it's not available, please send us an email and we can get it installed for you. So this is where you would get started. If you were interested in utilizing our systems to advance your scientific machine learning research, if you outgrow your local computer, or you want to run many different instances, and when we have it online, which will be very soon, if you want to run on the A100s, which I highly encourage you try out, you'll want to come to our webpage and come here to the quick links. There's the new user information and how to apply for accounts. So for the HPRC accounts, you will have to have a PI, and you will need to know who is PI eligible. Basically, if you're active faculty, you are PI eligible, but it's a few more than active faculty, research scientists, and there's a list of other people that are PI eligible. Okay, if you visit this webpage, it'll give you more information as to who is PI eligible. And if you don't know, if you have any questions, just contact us and we'll help you with that. So if you do get an account on our system, generally you want to just start with a basic account to get through the application process. You'll get a very minimal amount of service units that gives you access to a certain number of compute hours. If you are PI eligible, then you'll want to move on to a startup allocation, which gets you a larger number of SUs. And if you have very high computing needs, then you'll move on to a research allocation. Okay. So if you are not PI eligible, then you'll get a basic account and you will have to get your PI to apply for the startup or research allocation, and then they will sub-allocate you hours or SUs. So if you want more information about our resources, or if you have any questions whatsoever, please visit our webpage. Okay, you can email us at help@hprc.tamid.edu, or you can call our help desk number. At this time, I suggest emailing. If you do call our help desk number at the moment, since our help desk is working remotely, that number gets forwarded to my office. Okay? And if I'm not available to answer your call, please leave a message and we will get back to you. Okay. Okay, so with that, again, give me just a second. Okay, so with that, I want to thank you all for your time, and again for putting on this wonderful workshop. I'm really excited about this field of research. My history is I'm a computational chemist. So I believe that there's so many different scientific domains that can really benefit with a coupling of machine learning to improve the algorithms. And I know this is a burgeoning field of research, and I'm excited to see where it goes. So at this time, if you have any questions, please let me know. I think, yes, we have about 5 minutes for questions. So I know they said chat, but if you want to unmute yourself, feel free.
So there's a question from Ed Rhodes. Does HPRC have an email list for updates and classes?
That is a very good question. We actually don't, but we send emails to the TAMU opt list. And then we also send it to if you get an account on the HPRC systems, we do send out email notifications of upcoming short courses. But I feel that we will have sometime very soon a listserv that you can sign up for even if you don't have an account. So thank you for that question.
There's a question from Daniel McGlenny. When is the GRACE system going online?
Yes, so I cannot give you an exact date when it will be available to the general research population at Texas A&M University, but as I mentioned, it is currently being deployed. My suspicion is that it'll be early next year when it will be available for the general research population.
And there's a question from Emilio Coutinho. Can we apply to be a user tester of the new cluster?
You are more than I'm more than happy to have you email help@hprc.tami.edu, and you can ask that question, and we can put you on a list, find out what your research needs are, and then determine whether or not you can be added as an early tester. Yes.
Okay, there's a question from Lifan Wang. We are running an experiment that requires processing data within hours of acquiring the data. Is there a way to implement that?
So we would be very interested to talk to you about that. So if you could reach out directly to me, I'm going to go ahead and put my email in here. Anybody, actually, if you want to reach out directly to me, feel free. pres@tami.edu, and I would love to talk to you about that a little bit more. So yes, that is somewhat difficult when you have a multi-user HPC system, but we are interested in looking into the possibilities of exactly what you just asked about.
So Paul Cooler asked for your thoughts on Julia versus Python for speed. Is Julia pre-installed?
Julia is pre-installed, and if you need something other than what we have currently installed, we can update that. I actually cannot comment on that. Jintao is here. I think that he could.
Sure. So actually, Julian is very easy to install under your own account. You can just download and unzip it. It should be there. And relying on the system to install the latest version is always there's always a delay for us to install the latest one on the whole system. So I would suggest that you or your team to install Julia yourself on your own directory, and everything will be working just like normal. Nothing particular about that.
Can you comment on the speed difference between Julia and Python?
Yes, Julian has its very nice feature of so-called just-in-time compilation, which will be able to recompile your code and make it optimized on CPUs and GPUs. Depends on which device you want to use, and depends on the availability of the resources available on the nodes. So that's one major feature about Julia against Python. And the way how the Julia is designed, it's very similar to Python in some way, and it has a lot more features than Python doesn't have. For example, the Julian code that you write can be recompiled in time, and the performance is much faster than Python if you're just talking about a pure Julian code and pure Python code. But in reality, most of the Python libraries you're using will be relying on C libraries or Fortran libraries. So you might not see that much performance, but if you're just talking about the pure Julia code and the Python code, Julia is much faster. Yes.
Thank you. So there was a question about differences between the SH utility of Ubuntu versus HPRC. I think that really depends on what you're doing. So that's where our help desk would be very instrumental. So like I said, we don't have in-person help right now, but can set up Zoom sessions between the help desk and the researcher if you run into problems like that. So
Okay,
and I'll reach out to you later about that, Daniel.
Hey, well, Lisa, thanks very much. That's a great talk, and thanks everybody for your questions too.
Thank you. Let
Okay.
me stop sharing here.
We have a comment here from Levi, my student. TensorFlow is faster than Julia in graph mode, automatic differentiation. So that's the exception. So if you're working with scientific machine learning, automatic differentiation methods, then TensorFlow with the graph mode is probably the way to go.
Yeah, if I may, it's worth checking out that link. It has a lot of PyTorch and a lot of others are included in there. Oh, I'm sorry. Yeah, AD is automatic differentiation, sort of a crux of scientific machine learning if you're using it. And so TensorFlow, TensorFlow as it stands sort of edges out Julia in that particular context. But otherwise, Julia with the JIT compilation and all the other features of it is faster sort of natively. If you're using it, so yeah, it's just sort of worth it. There's exceptions, but yeah, Julia is typically faster.